Hello everyone, this is Prasad. I welcome all of you for another session on hybrid electric vehicles. I hope you are enjoying the lectures, and in previous lecture we have understood what are the most type of motors being used in manufacturing of electric vehicle. We have also understood what is MCU, that is motor control unit. We have also understood that is what is VSI, that is voltage source inverter, which is used to convert DC into AC and reverse in case of regenerative braking. We also understood what are different applications, advantages, disadvantages of different types of motors. Now, this is the concluding lecture on the eDrive system, which consists of motors, inverters, and controllers. So let's start the session, and first let's understand how DC motor drives are being controlled. Now here, in case of control of DC motor drives, there are two ways. Either it can be a armature voltage control or a field flux control. Now, when you are considering a DC motor, there are two ways that you can control the speed. Okay, I hope all of you know the speed is proportional to voltage and it is inversely proportional to the flux. So simply put, if you increase the armature voltage, speed is going to get increased, and if you reduce the field flux, speed is going to get increased. Okay, so speed is directly proportional to the armature voltage and inversely proportional to the flux that is produced by stator magnetic field. So let's understand this graph which you can see on your screen. On y-axis we are having various parameters such as power, the armature current, and the torque. On x-axis we are having omega, that is nothing but component of the speed. So here you will find, first of all, there is a high starting torque that is required, and further as we go ahead with increase in speed from left towards right, the torque is reducing. Here one point is mentioned, that it's base speed. Towards the left of the base speed, you will find it is written that armature voltage control, and towards the right of the base speed, you will find that there is written field control. So we have to take into consideration that armature voltage control method is used wherever you want to have speed control below the base speed. Now base speed is also called as rated speed. For example, if rated speed is 3000 rpm, so if you want to have speed control below 3000 rpm, you will control the armature voltage. If you reduce the control, or if you reduce the armature voltage, the speed will reduce. And once the motor achieves the base or rated speed, that is of 3000 rpm, if you wish to increase the speed above 3000 rpm, you have to control the flux. So if you reduce the flux, the armature, the speed will go on increasing. Very simple. So let's understand. So proper control techniques used to obtain desired speed torque characteristics for electric vehicles, and these techniques in case of DC motors involve armature voltage control and field control. So in the range of lower than base speed, the armature current and the field are set at their rated values, producing the rated torque. I hope you know rated values means what. For example, at your home you are having, suppose, 18 watt LED bulb. Okay, that 18 watt LED bulb is operating at 230 volts 50 hertz supply. So if you do basic calculation like 18 watt, 18 divided by 230, so its rated current will be around 0.07 ampere. Okay, simple calculations. For example, it is 0.7 ampere. Okay, then in this case, the equipment, if it operates at rated power, it is going to draw a rated amount of current from the required applied voltage. Okay, so lower than the base speed, when the speed is less than the base speed, for example, I gave you speed of 3000 rpm as an example. So if speed is less than 3000 rpm, the armature current and field are set at their rated values. So whatever rated values are there, these are mentioned on the nameplate of the motor. Like if you buy washing machine or if you buy a refrigerator, at the back side of the refrigerator you will find there is a nameplate. On that nameplate the standard values are given, like this is the wattage of the fridge, this is the liter capacity of the fridge, or this is the applied voltage of the fridge, this is the frequency on which the fridge operates. In same way, when you are having the nameplate of motor, it is having the HP rating of the motor, it is having applied voltage of the motor, it is having standard current or rated current of the motor. So in the range of lower than base speed, armature current and field are set at their rated values, whatever rated values there, producing the required torque. So here you can find initially high starting torque is required, Okay, and that is achieved by passing rated armature current. I hope you remember what is armature. Armature is on rotor, field winding is on stator. As we go ahead with increase in armature voltage,